If you take a few tiny, seemingly insignificant numbers and start multiplying them by themselves, the results quickly snowball out of control. That rapid scaling is exactly what players experience in Power Roller, a fast-paced dice game that demonstrates the true scale of bases and exponents. To get started, you just need to print out these 4 blank game boards. Grab a standard 6-sided die, some pencils, and a calculator for each player. This tabletop format shifts the focus to strategy and group discussion, requiring players to explain the math behind their choices as the round unfolds. Let's look at a single equation on the board. Each pair has a large box next to a smaller, elevated box. The large box is the base, the number being multiplied. The elevated box is the exponent, telling you how many times it multiplies itself. Before rolling, clear up a common pitfall. As this diagram shows, 7 to the 5th power is not 7 times 5. Instead, the exponent dictates repeated multiplication. It actually expands to 7 multiplied by itself 5 times. Grasping the structural difference between basic multiplication and exponential growth is the crucial step to driving up your final score. Here is how a turn works. A player rolls the die and writes the exact value into any single empty box on their board. You must place a number on every single turn, and once you write a number down, it is locked in. You cannot erase or move it later. This creates an immediate strategic dilemma. Players must decide if a rolled number yields a higher value as the base or the exponent. Given the numbers 7 and 10, which arrangement is larger, 7 to the 10th power or 10 to the 7th? 10 to the 7th is 10 million, but 7 to the 10th is over 282 million. One digit drastically alters the outcome. Forcing players to predict and debate these massive mathematical differences before they touch a calculator is what generates real, valuable classroom discussion. Play continues, passing to the left, with players rolling and writing until all 6 expressions on their individual boards are completely filled. Once the boards are full, players move to the computation phase, using their calculators to figure out the value of each of their 6 expressions. If you are working with beginners, require them to write out the full expanded form of their equations on scratch paper before they start typing. Looking back at the board, you will see a sum box at the bottom right. Players add the results of all 6 of their equations together to generate their master score and record it here. Under the standard rules, the player with the highest total sum wins the game. Seeing these individual rolls snowball into totals in the millions makes the explosive growth of exponents tangible for the first time. By the end of a round, students have combined repetitive computation practice with the logic of competitive strategy. But you can easily invert the challenge. Try flipping the win condition so that the player with the lowest total score wins, forcing everyone to completely rethink their placement strategy. You can also introduce 8-sided or 10-sided dice to handle larger values, or set a target condition where the first player to reach exactly 1 million wins. For advanced players, use the call your shot rule. Here, players must point to the exact blank box they are targeting before the die is even cast. Power Roller shows that paper and dice are enough to help students explore the true mechanics